I just want to check that my microphone is working. Thank you. Bye-bye. All right, honors pre-calculus, section 5.5. We've got multiple angle and product to sum formulas. There's a bunch of different formulas in this one, and some of these you will not have to memorize, like the product to sum formulas. Mainly the objective is to use these formulas to simplify or to make things easier to solve equations. So here's the first example. Double angle formulas. We derived these two formulas in our Desmos activity when we did section 5.4, and they came from the sum and difference formulas. From this one right here, you could replace the sine squared u with 1 minus cosine squared, or you could replace cosine squared u with 1 minus sine squared u. And then because you replace one of those, we get two other options for this exact same equation. So all three of those are related to the cosine double angle formula. And then there is also a tangent, which we did not derive from class, but it is available. So we're going to solve a multiple angle equation. Find the solutions of 2 cosine x plus 2 sine x equals 0. So, you know what? As I am doing this right now with you, I realize I believe I typed it in incorrectly because none of these fit the formula. So just let's go ahead and fix this. It should say sine 2x. I apologize, but when I'm typing up a bunch of stuff, typos do get made. So it should say this. All right, let's start it. 2 cosine x plus sine 2x equals 0. So we're going to use the sine 2u double angle formula. I will have 2 cosine x. I'm going to substitute sine 2x. I'm going to substitute that for 2 sine x cosine x equals 0. And now we're going to solve this equation, which we can solve by factoring. I'm going to factor out the cosine x. Oop, I lied. I'm going to factor out 2 cosine x. And I will have 1 plus sine x left over. So we'll separate these, set them both equal to 0. And where is cosine equal to 0? That would be at pi over 2 and 3 pi over 2. And then where is sine equal to -1? Well, that would also be at 3 pi over 2. So our general solutions would be that x equals pi over 2 plus the period 2 pi times n. Sorry, that's supposed to be a pi. Let me make it a little bit more clear. Okay. And 3 pi over 2 plus 2 pi n, and then that's where n is an integer. Example 2, using a double angle formula to rewrite the equation. So we've got y equals 4 cosine squared x minus 2. If I can factor out a 2, and then I'm just going to go back to that formula for just a moment here. 2 cosine squared x minus 1. Right here, I've got 2 cosine squared u minus 1, so that is the same formula. and that is equal to cosine 2u of y equals 2, and then we're going to substitute that for cosine 2x. Excuse me, y equals 2 cosine 2x. Now, if we needed to graph this, we could find, find where the x-intercepts are. I'm sorry. We could use our amplitude to go up to, down to our sinusoidal axis in the middle, and then this right here would affect our period. They have an example of a graph, but it doesn't really say that we need to graph this equation. Okay. Example 3. I'm sorry, guys, my throat is so tickly. It's not really my throat. It's whatever my my chronic cough is. So we're going to use the following to find sine 2 theta, cosine 2 theta, and tangent 2 theta. We know that cosine of theta is equal to 5/13, and that theta is somewhere in between 3 pi over 2 to 2 pi. So it tells us it's in the fourth quadrant. So if cosine is 5/13, then I know that cosine is 5, so x is 5. And then the radius would be 13, and then y would be 12 using our triple. So we're going to do sine 2 theta. And we're going to use the formula, which is 2 sine theta cosine theta. So that's going to give me 2. And then my sine, and here's theta, but well, there's theta, but here's my reference theta. My sine is 5/13. Oops, I forgot something. Well, it's not 5/13, that's a cosine, sorry. My sine is, that's what I forgot, negative 12/13. And then my cosine would be 5/13. And so we're going to just multiply all that together. We'll get negative 120 over 169. And that does not reduce, so that would be the answer. Let me change color. I haven't been changing color. So question B is going to be cosine 2 theta. So we're going to use the cosine formula, which is 2 cosine squared theta minus 1. And actually, we could use any 3 of those cosine theta formulas. There's like 3 of them. It doesn't really matter which one we use. Just I'm going to use this one since we were given the cosine, so I know for sure that it's 5/13 and I didn't make any mistakes. So we'll get 2 times 25 over 169 minus 1. So that will give me 50 over 169 minus 169 over 169, which equals negative 119 over 169. Okay, and question C is tangent 2 theta. And the formula from the previous page says to do sine 2 theta over cosine 2 theta, which we just found the answers for. So we'll have negative 120 over 169 divided by negative 118 over 169. Instead of dividing by a number, I can multiply by its reciprocal. So the negatives will cancel out, the 169s will cancel out, and I will get 120 over 119 for the tangent. And that's just coming from these formulas here. So this one right here uses a tangent, which we could have used that formula instead of just putting sine u over cosine u. Either would have been fine. Oops, I meant 2u. Sorry, I said it wrong. So those are equivalent as well. It just depends on the information that you already have. Okay, example 4 is deriving a triple angle formula. So we already have double angle formulas. We can make a triple angle formula if we want it. And we're going to use the sum of the sine formula that we just learned in 5.4. So the formula says to do sine 2x cosine x plus cosine 2x sine x. Now, where I see sine 2x and cosine 2x, I'm going to replace those with the double angle formulas. So sine 2x is 2 sine x cosine x. Oh, sorry. Yeah, sine x cosine x. And then we also have that other cosine x to bring down. And then cosine 2x, we can use any of the three formulas that are up there. But since I am multiplying it with a sine x, I think I'm going to use the one that is, all sines. So 1 minus 2 sine squared u. Times by sine x. In my next step, I will have 2 sine x cosine squared x plus, now I'm going to distribute the sine x, so sine x minus 2 sine cubed x. At this step, I'm going to take out the cosine squared x and change that into sines as well. Get 2, oh, I've got an x here, 2 sine x, and I'm going to multiply that by 1 minus sine squared x. Plus sine x minus 2 sine cubed x. And distribute here, I'll have 2 sine x minus 2 sine cubed x plus sine x minus 2 sine cubed x. And finally, I'm going to combine some like terms, and we will have 3 sine x minus 4 sine cubed x. So we just derived a triple angle formula, and really if we could get a triple angle formula, we could probably get any kind of angle formula that we want by just using the same process. All right, now we have power reducing formulas. If we have a sine squared and we don't want it squared anymore, we can use this power reducing formula where like sine squared equals 1 minus cosine 2u divided by 2, and that way it's not squared anymore. We have a cosine squared u where that will reduce down to just cosine 2u, so we get rid of that power. Or we have tangent squared u, which divides the sine u and the cosine squared u And then the 2's cancel out, so we get it down to a power of 1. So these are used often in calculus. So we're going to rewrite sine to the 4th x as a sum of first powers of the cosines of multiple angles. So the first thing that I'm going to do is just look at this sine to the 4th x as sine squared x and then squared. So I can get to this sine squared here. Oopsies. That always goes too far. Okay. Now from here, I'm going to replace with 1 minus cosine 2x over 2 squared. And as I'm working on that step, let's see, if I square the top and square the bottom, I would have 1 minus cosine 2x squared and then just over 4. So my next step is I'm going to actually FOIL the top. I'm going to get 1 minus 2 cosine 2x plus cosine squared 2x, right? Yeah. And then that whole thing is over 4. Okay, so now I have another cosine squared in here, so I'm going to use this formula to get rid of the cosine squared. Now 1 minus 2 cosine 2x plus, I'm just got to be a little tricky here because we have this 2x, that would be like the u, and then up above it has a 2u, the cosine 2u. I'm going to be multiplying the 2x with another 2 when I put it in. So I will have 1 plus cosine 4x over 2. And then this whole thing is over 4. Let me separate that dividing by 4, which is also aka also known as multiplying by 1/4. I'm going to distribute that 1/4 to everything. So I'll get 1/4 minus 1/2 cosine 2x plus, so if I'm multiplying this by 1/4, I'm going to get 1/8 plus cosine 4x over 8. So now, let's see, these are like terms. I'm running short on space, sorry guys. Those are like terms, so I could add those together. And let's see, this would be 2/8. So it'd be like 3/8 minus 1/2 cosine 2x plus cosine 4x over 8. And really, we've kind of achieved our goal in this last couple steps. I'm just making it look a little bit nicer. The last step that I'm going to do is I'm just going to factor out that denominator. It would be a 1/8 that I would take out, just so that we don't have a bunch of fractions that are different everywhere. So it'll leave me with 3 minus, and if I take out a 1/8, that's the same thing as multiplying by 8. So I've got 4 cosine 2x plus, and then cosine 4x at the end there. So there we've achieved it. We've actually achieved it all the way down to here is where we've achieved it. And then, like I said, just at the end, I was kind of messing around with it, making it look a little bit nicer. right, the half angle formulas would be, they're similar to the previous power reducing formulas, where we had like sine squared equals 1 over cosine 2u, no, 1 minus cosine 2u over 2. It's similar to that, only now it's plus minus square root. So we we're going to be using plus minus and the square root. So the plus minus, that just has to depend on which quadrant it's in. So you're not going to use both of them. You're going to use which one it is, depending on the quadrant. So these are called half angles. And we look at example 6, and we're going to find the exact value of the sine of 105 degrees, which I don't know. But I do know that 105 multiplied by 2 is 210 degrees, and 210 degrees is a 30 degrees reference angle, and I can find the sine of 210 easily. So we're going to go off of that. We're going to use the half angle formula for sine. We're going to, we're going to say that sine 105 degrees is equal to the square root, so now I'm using the formula, of 1 minus, and then you'll notice in the formula up here, it has cosine and it has the full angle. So over here we've got the angle divided by 2. Here we've got the full angle. So this is going to be cosine of 210 degrees divided by 2. So I'm going to do 1 minus. I can find the square root of 210 degrees. That is square root of 3 over 2. I said square root, I mean the value. And that's going to be all over 2. And so on top, I can find a, let's see, how do I want to do this? I can find common denominator. So I have like 1/2 minus square root 3 over 2, and then that all over 2. So 1 minus square root 3 over 2 divided by 2. This is still under the radical. So instead of dividing by a number, we could multiply by its reciprocal. So instead of that, we can multiply by the reciprocal. So I've got square root of 2 minus 2 radical 3 over 2. I guess I could just cancel these. Yeah, let me do that. So I get 1 minus square root 3. There's something wrong. What am I doing wrong? So I'm making a mistake. I'm sorry. I'm recording a video and I'm making a mistake and I'm trying to figure out what I did wrong. Oh, I know what I did wrong. Okay, I apologize. Let's go back just a teeny tiny bit. If you are following along and you found my mistake before I did, gold star. If you didn't find my mistake, this was like negative square root 3 over 2, so I should have changed this to be plus, and I didn't do that. What am I doing here? What color? Don't think that's my only mistake though. Oh, here's my other mistake. It's silly. There we go. When I found my common denominator, I just didn't change the top. There we go. Oh, so messy. One more try. Should just be a 2 up there. Okay, back to where I was. All right, so now on top I've got square root and then 2 plus square root 3 over 2 divided by 2, which is the same thing as multiplying by the reciprocal. So now I have square root of 2 plus square root 3. One more time. So as soon as I just thought about it a different way, it came to me. Okay, so instead of dividing by 2, I should be multiplying by the reciprocal, which is 1/2, not 2. That's what I did before. Okay, so one more time. So I'm going to get, if I multiply by 1/2, I'm going to get 2 plus square root 3 over 4, and this whole thing is in a square root. So if it's all in a square root, I'm going to separate that to be square root 2 plus square root 3 over square root 4, which gives me square root 2 plus square root 3 all over 2. There we go. Finally got it. All right, so that would be the exact answer for the value of sine of 105 degrees. And I apologize, it's kind of late and I could not find my mistake. But it happens to the best of us, right? Right. Okay, find all the solutions of 2 minus sine squared x equals 2 cosine squared x of x over 2 in the interval from 0 to 2 pi. Ooh, and this is a fun one. Okay. So the first thing I want to do is notice that we have the x over 2. Oh my gosh, there was one more thing. I'm so sorry. I meant to say it out loud and it never happened. Originally, because this was in the second quadrant, 105 degrees, that's why we used the positive value, because sine is positive in the second quadrant. So that's why I never had a negative sign. I had a positive sign for all of these. Sorry about that. Meant to say that earlier, but then I got stuck on the other thing. Here we go. Find all the solutions. And the first thing I'm going to do is take care of this part. So we've got 2 minus sine squared x equals, I'm going to have 2. And then in the parenthesis, I'm going to put plus minus. I'm going to use the formula for the half angle. And then after that, that's going to be squared. So that's how we'll take care of that squared. So the formula for cosine x over or u over 2 is a big square root 1 plus cosine x over 2. So my next step would be 2 minus sine squared x equals 2. And then I'm going to square the square root. And when I square it, it'll change plus minus into just positive. And I will have my square root will cancel out with my squared. 1 plus cosine x over 2. And then we can distribute the 2, and not really distribute, but just multiply. And that will cancel over here, so I get 1 plus cosine x. Now I need to solve this. So since I have a sine squared x in it, I will use my Pythagorean identity to say 2 minus, and then this will be 1 minus cosine squared x equals 1 plus cosine x. So 2 minus 1 plus cosine squared x equals 1 plus cosine x. And I'll go ahead and put everything on one side so it equals 0. Let's see, 2 minus 1 is 1. We're going to take away 1, so that's going to cancel out. I'm going to have cosine squared of x minus cosine x on one side. Now that is factorable. So I'm going to factor out the cosine x. And we're going to solve each factor. So cosine is 0 at pi over 2 and 3 pi over 2. And then cosine is 1 at 0. And then I'm going to put these in order. 0, pi over 2, 3 pi over 2. All right, then we've got product to sum formulas. So the product to sum formulas are derived from our sum and difference formulas. This would talk about if we have a product first, sine u multiplied by sine b, we can separate that to a difference of cosines, or half a difference of cosines. We start with cosine u multiplied by cosine b, we've got a half of a sum of cosines. If we've got one of each, sine u cosine b or cosine u sine b, then we've got the difference in sum or sum of sines. So we're going to write a product as sums, or writing products as sums. So this says cosine 5x sine 4x. So I'm going to look up here and we're going to look for which one has cosine, then sine. And that looks like this one right here. So I'm going to have 1/2, and then we're going to have sine 5x plus 4x minus sine 5x minus 4x. I'm going to simplify that, and we get sine x minus, 9x minus sine x. And then I guess I could distribute the half sine 9x minus half sine x. And that's it. And then taking those product to sum formulas, we can do sum to product formulas, which is solving for the sine x, sine y portion of it, moving everything around to the other side. So we've got 4 formulas for that. And for this one, we're going to find the exact solution of cosine 195 plus cosine 105. So we'll be using this formula right here. So I'm just going to plug in, let's see, 2 cosine. We'll have 195 plus 105 over 2 cosine 195 minus 105 over 2. So we've got 2 cosine. This will be 300 over 2, so 150. And then cosine 45 degrees. Oopsies, 45 degrees. So we've got 2, and then the cosine of 150 is, that was not a good example. Like that. No, I lied. It was better the first time. One more try. So 150 has about 30 degrees left over. So the cosine of that, it's going to be negative square root of 3 over 2, and then the cosine of 45 degrees is square root of 2 over 2. So those 2's will cancel. We'll get negative square root of 6 over 2 for our exact value. And then example number 10 is solving a trigonometric equation. We're going to find all the solutions of sine 5x plus sine 3x. So this is these are sums, and I can use the sum to product formula. This one has the sine x plus sine y, so I'm using the first of those formulas, which I'm just going to, I'll just write the equation right up here. I mean, you can look it up in your book or in the notes above, but I have it off to the side, so I'm just going to write it 2 sine x plus y over 2, and then cosine x minus y over 2. So we will have 2 sine 5x plus 3x over 2, and then cosine 5x minus 3x over 2, and that equals 0. So 2 sine, this is 8x over 2, 4x, cosine 2x over 2, so x. So now this is actually factored. So we can take sine 4x and set it equal to 0, and cosine x and set it equal to 0 as well. So let's see, cosine x equals 0 is going to be just pi over 2 and 3 pi over 2. Sine x equals 0. Sorry, sine 4x equals 0. The 4x itself would be 0 plus, okay, so that's going to be 0 and pi. And if I add pi, it gets to the other one. So plus pi n. So I don't even need to put the second answer because 0 and pi. If I add pi on, it already gives me the second answer. Then I'm going to divide by 4. So x would be pi n over 4. Now, if I'm using pi n over 4 as my general, where n is an integer, as my general solution, will that also include these? So if I'm doing all the pi over 4s, pi over 4, 2 pi over 4 would also be pi over 2, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4 would also be 3 pi over 2. So that does include both of those in it. So we don't need to say anything extra other than this part of the answer, because that will include the cosine parts. All right, the very last example that we have is verifying a trigonometric identity. And we've got verify this identity, which, is we can use the sum to product formulas that we were just looking at. And the sine x plus sine 3x would be like the very first formula. Oh, by the way, I'm going to make it say equals tangent 2x. So I'm going to change the left side. So sine x plus sine 3x is going to be 2. And then it's going to be sine, we've got x plus 3x over 2 cosine x minus 3x over 2. I'm going to do the exact same thing with the bottom, only it's the cosine plus cosine, which is the third formula in that box. So I'm going to have 2 cosine x plus y. Nope, not x plus y. Sorry, that was from the formula. X plus 3x over 2. And then it is another cosine. X minus 3x over 2. So I'm going to simplify this, and on top we'll have 2 sine, and that's going to give me 4x over 2, which is 2x. Cosine, that's going to give me negative 2x over 2, which is negative x. And then on the bottom, we're going to have 2 cosine 2x cosine negative x. Now these are factored. There's no addition between them or subtraction between them. They're all factors. And if something can factor out, it can cancel. So those can cancel. And these can cancel because they can factor out. So now I have sine 2x over cosine 2x, which is the same thing as tangent 2x. All right, I think the biggest, the toughest part about this section is there's so many formulas. And this is a big question here. So there's so many formulas. When do I use which one? This is where you want to take your time and you want to make sure that you ask questions if you're unsure. Okay, we will see you in class soon. Have a great day.